Hello and welcome. In this video I'm going to complete a series of tasks for ISIS on OcNOS devices. As you can see, my topology, there are multiple domains. The main domain which I'm going to work on is this one, which is marked with area 1, and it contains 3 different routers connected to each other using a broadcast network. The task says core-to-core links should only form L2 adjacencies, which means that I should make sure that only L2 adjacencies are available on this link on this broadcast network. This is pretty easy, and I'm going to do it in the beginning. And there are 2 different ways to achieve that, but because we want to make sure that the later connections are going to continue the trend, then what I need to do is to go with configuration under ISIS protocol itself. The second one says that set core-to-core link matrix to 1000. You should know that by default the metric for each link is 10. ISIS does not have any algorithm to calculate the metric for the interfaces such as what OSPF has. For example, on OSPF we have a reference bandwidth, and based on that you can decide what is the cost for this specific interface. You can of course have such thing in your mind and change the interface cost based on that, and this is exactly what we are trying to do here. Here it says that the link should be marked with a metric of 1000. The second thing about metric that you should know is the metric has 2 different ways of setting. The normal metric, which is called the narrow metric, is by default 10 for each interface. The minimum is 1 and the maximum can be 63, and the cost of a path from source to the destination, which is the sum of the metrics on the way to the destination, cannot exceed 1023. Now in some of the applications, when we want to, for example, go for traffic engineering, for example, the cost cannot really be considered a valid cost for calculating the path to the destination. So what we are going to do is to increase the cost to something which is more sensible, and for that we need to use wide metric. In wide metric, the minimum is 1 and the maximum cost for an interface can go up to 16,777,000 something, which means that that's a 24-bit number, and the total sum of costs from the source to the destination can exceed something like 4 billion, which is a 32-bit number, which is quite nice. Now we need to make sure that wide metric is enabled to achieve this goal. The last one says that the core-to-core link should use IETF 3-way handshake. When you see this, this means that we need to go with point-to-point connections. Now in my case, of course, the core area, which is my backbone, is connected using the broadcast network, so you cannot really go with point-to-point connections here. But the connections between, for example, router 2 and router 7 and some other connections that you can see, all of them could be configured as point-to-point, and this is what I'm going to do in this task. So let's start. So the first thing, I'm going to make sure that L2 adjacencies is going to be there. So if I just go to router 2, for example, and I'm going to configure Ethernet 1 and Ethernet 3. So if I just go to router 2 and go to configuration mode and interface Ethernet 1, for example, I can do something. I can just say ISIS, and after that there is a command that says network, and if I say network, after that you can see that we have broadcast and point-to-point. Broadcast is the default, but if you go with point-to-point, this makes sure that 2 things are going to happen. First of all, the 3-way handshake is going to happen, and the second of all, there is not going to be any designated IS on this specific network. So I can just do this and hit enter. Before committing, what I'm going to do is to say do show CLNS neighbors. That is going to show me that R7 for now is a neighbor. Now as soon as I say commit, this is going to remove R7 from my adjacencies. So I do this and do not see R7 there. That is because R7 does not agree on this type of a network. So what I'm trying to do is to go to R7 and I'm going to go to configuration mode, interface ETH1, and I'm going to say ISIS network is going to be point to point, and hit enter. And I'm going to say commit. Now going back to R2, I can do the verification one more time, and you can see that R7 is again here. For now the state is down, but if I try it again, you can see that the state is up right now. Now if I say do show ISIS database and hit enter, you can see that for R7 there are two different LSPs. This one, of course, after something around 20 minutes is going to time out and you're not going to see this anymore. That is because this one belongs to the designated IS. In previous configuration, R7 was the designated IS in the broadcast network, but after some time you should see that this is going to go away and the whole time is going to reduce and vanish. So you can see that the whole time is not refreshing anymore. If you want to see the contents of that, all you need to do is to say show ISIS database and this LSP ID, and after that you can say detail and hit enter. That says that R7 was the designated IS for this specific network. Okay, let's go back to the actual task. The task says this should be done in a way that this part of course is done. And now the first one, it says that the core-to-core links should only form L2 adjacencies. Now there are two ways to do that. One more time, what I'm trying to do is to make sure that the interface is going to form L2 adjacencies. If I just go up and check the connection between R7 and R2, you can see that L2 adjacency is formed and there is no problem. And if I just go back to topology, the reason for that is quite obvious, because router 7 and router 2 are in different areas, and the rule for ISIS says that router 7 and router 2 cannot form L1 adjacencies because they are in different areas. So that's okay. But what about between router 4 and router 2? If I want to make sure that this is going to happen, I need to go under interface or under router ISIS and configure this as L2. So under router 2, for the interface ETH3, I could say ISIS, CLNS, and circuit type, or no, ISIS circuit type is L2 only. That is one way to do that, level 2 only, and hit enter. And that is one way to do this and achieve this. But because the task says that everything should be under level 2 for now or for any other future configuration, this is not the way to go. So what I'm going to do is to say no ISIS circuit type level 2 for now. And what I'm trying to do is to go to router ISIS, and of course OcNOS is the instance name. And under that I'm going to say IS type is going to be level 2 only. That's it. And hit enter. I have done this before, so committing this is not going to affect anything, but just for now you should know that this is going to impose level 2 on all the interfaces for now and for the future. So one more time, if I say do show CLNS neighbors and hit enter, you can see that all my neighbors are level 2 only. What about other routers? If I just go in my topology to another domain on the right, for example this one which is marked with area 5, and I'm going to check the adjacencies between router 7 and router 5, and then I'm going to check the configuration of router 5. So first of all, let's see router 5. If I say show run, and I'm going to go down until I get to here, I have marked this with level 1. This means that our router 5 can only form L1 connections. So if I say show CLNS neighbor on this and hit enter, you can see that I only have L1. But if I remove this command, what is going to happen? So let's do this. I'm going to go to router ISIS OcNOS, and I'm saying no IS type and hit enter, and I'm going to commit this. Now I should do the same thing on router 7. I want to make sure that router 7 is going to form both L1 and L2 connections. So by default I know that router 7 does that because it has already adjacency created with router 5. So if I just say do show run and go down to get to here, you can see that it says IS type is level 1 2. So that is the default, and for R5 for now it's going to be the same. So now if I say show CLNS neighbor, you can see that I have this L1 adjacencies, but after some time, let me see, did I commit this? Yes, I did. Do show run. I'm going to check to see whether this is reflected in my configuration. It doesn't. So what I'm going to say is IS type is going to be level 1 and 2. Hit enter, and I'm going to commit. And now if I say show CLNS neighbor, after some time you should see that there are two adjacencies on this specific link, and one of them is L1, one of them is L2, and that's going to happen for us. So I need to just wait for that. And let's just go to router 7, and the configuration says level 1, level 2. Did I have any configuration under the interface here? So if I just go to Ethernet 2 on router 7, I can just see that. Do show run interface Ethernet 2. Yes, as you can see, I already have ISI circuit type level 1 under this, which is going to make sure that only level 1 connection is going to happen. So I should remove this interface ET2. I'm going to say no ISIS circuit type and hit enter. I'm going to say commit. Now going back to the configuration one more time, there is no such thing. What about router 5? Does it have such configuration here? So if I say do show run interface ET2, it says there is such thing here. So I'm going to remove this as well. No, and interface ET2, no, and I'm going to commit this. And now this is the default behavior of the router. So if I say do show CLNS neighbor, you can see that by default there are two adjacencies to the same device. One of them is L1 and one of them is L2. But the problem would be when I have L1 and L2 at the same time, I'm going to receive all the routes here on router 5. Router 5 is an edge router. Maybe this is not an maybe this is a low-end router. Maybe it doesn't have the capacity to handle a lot of routes. Maybe I don't really want to have so many routes on this router because this is an edge router and the only thing that it has is one connection to this L1, L2 router and one connection to the rest of the network. This one connection doesn't need anything more than a default route. So that is one of the reasons that R5 should only form L1 connections. So if I just go to R5 one more time and say do show IP route, you can see that I'm receiving a lot of routes from different parts of the network. I don't really want it. This one, of course, is left from before, and after some time this is going to timeout, so I'm not going to have it anymore. But let's do that one more time. I'm going to go to router ISIS OcNOS, and what I'm going to do is to say IS type is going to be a level 1. That's it, and hit enter, and I'm going to commit that. So this makes sure that I'm going to create only level 1 adjacency, and the other router, because that's an L1, L2 router which is connected to another area, has the attached bits set on that, which means that I'm going to receive only a default route. So if I say do show IP route for now, you can see that this default route is here, and I can use it to reach to other parts of the network without any problem. I know about 6666 because it is in the same area as I have been configured with. I know 7777 because this is again in my area, but I don't know anything about 1, 2, 3, 4 and other routers in the network. So we have achieved almost every part of the configuration. For this, of course, like I said, when we configure point-to-point, there is a verification, interesting verification way. So that is interface Ethernet 1. I can just capture this interface Ethernet 1, capture ETH1, and then you can see that there is a point-to-point on the messages which is sent on this link. So let's say, for example, this hello message, and if I just open this, you can see this point-to-point adjacency state which says this is set, and the TTL of course is set to 240, and the type, sorry, is set to 240, and everything is the way that we really want to have it. What about this one that says set core to core link metrics to 1000? I'm going to stop this capture because we don't really need it. For this, like I said, we need to make sure that white metric is going to be enabled, and I should enable it almost on all routers here. So what I'm going to do is to say white metric is going to be enabled for here. So let's do that. I'm going to go to router 2, 4 and 3. So let's do this. On router 2, I'm going to say metric style is, you can see we can go with narrow, which is the default. We can go with transition, which means that we are using both sides of TLVs during transition, and we can go with wide. So this is wide in my case, for example, and after that you can say for level 2 only, for level 1, or for everything, because for now the task says core to core links only. So I'm going to go with level 2 only. So just that, level 2, hit enter, and I'm going to commit this. The same thing on router 3 and router 4. So let's just copy this line of command and go to here and hit enter and commit, and router 4 the same thing. So I'm going to say commit. Okay, so let's go to router 7 first of all, because this is a router that I have not configured any metric style on that. If I just go to here and say do show ISIS interface, let's say for example ETH2, and hit enter. In the end of the command, there are some interesting information, not in the end, of course, in the middle. So here it says the metric is 10 and 10. The first one, of course, is narrow metric. The second one is white metric. I have not changed the white metric right now. And to change the white metric, what you need to do is to say ISIS white metric, and after that, enter a value. So if you say ISIS metric, that is going to just configure the narrow metric for you, and you can see that the narrow metric, it goes from 1 to 63 only. Now it is not like some other platforms that you can just say ISIS metric and after that enter a value. If it is over 63, that would be considered white or not. This is two different commands that you can see here. Now going back to router 2, of course, because I have not configured anything, and like what you saw in router 7, the default white metric is 10 as well, I should just change it to some value. So here, the interface from router 2 connected to the network, if I say show IP interface brief, that's going to tell me that the interface which is connected to my network is Ethernet 3. I would go to interface Ethernet 3 and I would say ISIS white metric is going to be 1000 per the request, and hit enter and commit. On router 3, if I just say show IP interface brief, it says that Ethernet 4 is connected to this section of the network, interface Ethernet 4, and I'm going to say ISIS white metric is 1000 and commit the configuration. And finally, router 4 to show IP interface brief says that I am connected using Ethernet 2. So interface Ethernet 2, and I'm going to say ISIS white metric is going to be 1000 and hit enter and commit. Okay, now let's check the configuration and verify everything. To show ISIS interface, and the interface which I'm interested in this platform is EAT2. EAT2, and it says that here somewhere the metric is here. The narrow metric is configured as 10, the wide metric is configured as 1000. And of course there's a priority value which we are going to use it to make sure that this device is a designated IS or not. Of course we are not working with that for now. Metric is of interest for us. So that is what we have. And to show CLNS neighbor says that we have the adjacency with router 2 and 3 and router 4, which is quite awesome. So that is how you configure metric. And if I just check the tasks, I have achieved the goals for all the tasks. So I hope this has been informative for you, and see you in next video.